we build models because we're human and we want to.
It's not about learning physics. It's not about learning about forces or any of those things. It's about learning to solve problems in a way that is reproducible and doesn't overwhelm you.
A model for me would be an equation. It could be a graph. It could be a diagram. It could be like a model, like most people would think of a model, like a model airplane or a model train or a model of the atom.
We also worked with lower resolution models, so this material could serve as a very good model for the elastic properties of DNA.
I think all models start with observations or an experiment because science is based in the physical world.
In general, we look for a new law by the following process. First, we guess it. Then we no, don't laugh, that's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature.
Models are only as good as how well they predict the behavior of the natural world. If they don't predict the behavior of the natural world, I'm sorry, your model sucks.
It's often been said that the most successful models are those that destroy themselves because they make predictions that go beyond the range for which the model is actually valid, and when the model breaks down is when you begin to get new insights about, the world works a little differently than we thought.
If it disagrees with experiment, it's wrong.
It's Newton's law of gravitation. Awesome model, works beautifully for our solar system, works beautifully for everything here on Earth. But you go out and you look, and the observations you make from tons and tons of galaxies say, no, actually Newton's law of gravitation doesn't work so well. And so then you ask yourself, well, what's going on here? Newton's law of gravitation does work in all these other situations. Why doesn't it work here?
The same thing is true in experiments. Many successful experiments are those that fail. You get a result you don't understand, and then you've discovered something if you can explain why it didn't work the way you thought it would.
The question arises, why do you see what you see, or observe, or measure? And that's where models come into play.
People say to me, are you looking for the ultimate laws of physics? No, I'm not. I'm just looking to find out more about the world.
You know, science is not about finding the truth. It's about making models that work, and these models work, so we use them.